Building a high-end 3D environment usually means facing massive technical debt before starting creative work. You are constructing a world out of raw polygons. Most of that work is highly repetitive. You spend hours untangling complex node trees, managing object hierarchies, and renaming thousands of assets. It is a steep technical climb that consumes most of an artist's day. That specific grind is the target of a new partnership. Anthropic, the team behind the Claude AI, has officially joined forces with the open-source Blender Foundation. This is a deep institutional commitment. Anthropic joined the Blender Development Fund as a corporate patron, contributing a minimum of $280,000 to the software's core development. This funding fuels an official integration that puts Claude's neural network directly inside Blender's interface. But there is a gap in how this works. Claude is a cloud-based language model, while Blender is an offline application on your local hard drive. How does a remote AI physically modify geometry or bake textures on your personal computer? Bridging that communication gap is the specific key to removing the technical friction of 3D design. The bridge is a system called the Model Context Protocol, or MCP. It provides a standardized way for cloud-based AI to interact with local files and creative tools. Instead of clicking buttons, Claude generates Python code. A simple text prompt transitions into a functional code block. The MCP local server acts as a delivery agent. It receives cloud code, moves it through a TCP gateway, and executes it inside your Blender scene. Creating this local pipeline requires 3 specific technical layers. First is the software. You need Blender 5.1 or newer to support the official integration add-on. Second is the client. This is an interface that speaks the protocol, like the Claude desktop app or the cursor editor. Third is the server. You run a local MCP server in the background to handle the communication between the AI and your hard drive. Stacking these layers together creates a responsive, programmable environment where the software can act on its own logic. This is the domain of vibe coding, where plain English prompts replace the constant cycle of menu diving and manual tool selection. For example, if your viewport performance is lagging, you can tell the AI to analyze the scene and optimize the geometry. Claude uses a diagnostic tool called Get Scene Info to scan your outliner. It looks for high-poly objects that are causing the bottleneck. It then writes a script to dial down subdivision levels or simplify meshes, executing the fix without you ever touching a modifier stack. The AI can also verify its own work. It captures screenshots of the 3D viewport and sends them back to the cloud so Claude can see if the geometric changes matched your intent. These visual feedback loops ensure the AI is a state-aware collaborator that understands the current condition of your scene. This isn't a magic button for generating finished 3D characters. A single prompt won't build a photorealistic, production-ready model. It is agentic design. The AI functions like a junior technical artist that handles the scripts, the scene setup, and the organization, while you handle the creative vision. But local execution has a major security catch. Because the AI is writing Python code for your machine, those scripts bypass normal security sandboxes. They have a direct path to your core system folders. This means the AI has the authority to run commands on your physical hardware. You have to treat every generated script with caution, as it could potentially alter your local files. Despite the risk, the technical barrier to complex 3D creation has dropped. The tedious middle of the workflow is being absorbed by code. 3D creation is becoming a role of pure orchestration. The artist directs the system's logic, commanding a pipeline that translates high-level intent into geometric reality.